using the fundamental theorem of calculus 2 notes, excuse me, you're going to want to grab your TI-83 or your graphing calculator. A lot of what's happening here on the backside is using the graphing calculator. Unfortunately, I don't have a graphing calculator that I can pull up on my computer. I don't have a graphing calculator emulator, so I'm just going to need to talk you through how to do this. So the first thing I'm going to want you to do is we're looking at this velocity function. It's kind of a complicated velocity function. So you're going to want to take this and put it into your graphing calculator under Y1. And if you've got it into your graphing calculator correctly under Y1, then you'll get this graph over here. It'll look like this. So pause the video, try that, make sure you can get on the graphing calculator your Y1 to be that. All right? Great, now you've got that, you're back, and our first question, or actually B here, we want to find the total distance. So total distance, we don't care whether or not we're going positive or we're going negative. So that means that we're going to want to look at this area here, area being positive, look at this area here, and look at that little teeny area there, and we're going to add them all up together. And in order to do that, what we're going to need to know is we're going to need to know what that point is right there. Right? So we've got minutes on our x-axis, we've got velocity on our y-axis, and the question is, when is the velocity equal to 0? So to do that on your calculator, right, you have your graph on your screen, and you're going to do second calc, and then you're going to find the 0. And if you've done that correctly on your calculator, and you should try that right now, you should get that this point here is 1.86. And this point here, the second 0 that's important, is going to be 4.53. And then the last 0 that's going to be important is 5, right there. So if we want to find the total distance, the first way to do this is to find the three integrals. So the first integral being the integral from 0 out to 1.86 of our function, vt dt. And you should try that on your graphing calculator. Again, pause the video, grab your graphing calculator, make sure that you can do second calc and find the integral from starting 0 ending 1.86. Alright, so now you're back and you've started the video again and you're checking to make sure you got this correct. So you should have on your calculator gotten 2.13, and then we'll do the second integral. Right, so that's this first integral plus the second integral, and it's going to be the integral from 1.86 out to 4.53. Our function, it's going to be y1. Right? We're writing this as vt dt. And again, pause the video, grab your graphing calculator, find that integral on your calculator, and if you've done it correctly, your calculator should tell you that that is negative 3.44. We're looking at the total distance, so the negative is irrelevant to us. We don't care that it's going to the left. We just want to know that we're just interested in the 3.44. And then we do the last interval, which is the integral from 4.53 out to 5 of the function. And again, pause the video, grab your graphing calculator, do that, and then you've unpaused the video and you're back and you're checking to make sure that you got 0.09. So we can add up those we can add up those three intervals. If we're doing displacement, which is the first one that Mr. Friedland's got here. So if we're doing displacement, the displacement is going to equal 2.13 plus the minus 3.44 plus the 0.09, which is going to be equal to 1.22 miles. And if we're doing distance, that's going to be equal to the 2.13 plus positive 3.44. Distance is always positive, plus the 0.09, and we should get 5.66 miles, right? So that's method one. Method one, cut it into its three pieces and then build the displacement and build the distance, paying attention to the positive and the negative. So the second way to do this is to pay attention to how you're putting this into the calculator. Okay? So if you're putting v of t into the calculator and you do the integral from 0 to 5 of v of t dt, well, you're going to get displacement because the integral is going to pay attention to positive and negative. So the integral will be where you were at the end minus where you were at the beginning. And if you do that on your calculator, you will find that it tells you that the displacement is, and you should pause the video and check to make sure you can do this on your calculator, because this is the kind of thing you want to be able to do on the AP exam quickly with your calculator. So pause the calculator and make sure the integral from 0 to 5 does indeed give you, negative 1.22 miles, just as it did up above when we broke it into its three pieces. And if you're finding the distance, if you're finding the distance, so what you want to do is you want to go in and your y1, what you want to do is take y1, where it says y1 equals, go in and insert ABS, and then the function. So you're going to take the absolute value, and probably the quickest way, actually I'll give you an even quicker way to do this. So leave y1 as it is, and make a second function, and the second function, y2, you're going to make equal to the ABS of y1. And then when that's in the calculator, you can use y2 to find the total distance. So if you're looking for the total distance, then that's going to be from 0 to 5, the absolute value of your function dt, which on your calculator should give you, and you already know what the answer is supposed to be, but you should check to make sure you can do this on your calculator. It should be 5.66 miles. All right, so continuing on, I'm going to go sort of back and forth between our graph and these questions. So first question, when is the velocity the greatest? Velocity cares about whether it's positive or negative. So if we're caring about whether it's positive and negative, we are only looking at the positive, and there aren't very big velocities here. The big velocities are over here, and the largest velocity is going to be up over here. So you want to see whether or not you can get your calculator to identify that point. And if you've done it correctly, you should find that the velocity is the greatest at 0.9 minutes, and that the y value there is 1.81 miles per minute. Right, so you should check to make sure you can find those values with your calculator. Speed, we don't care whether it's positive or whether it's negative. So we want to know, is there a place where we have a speed that's greater than 1.81 minutes? Right? So the 1.81 minutes is right up here. So the question is this, the absolute value of this velocity, going to be larger? So you want to see, use your calculator again to find the coordinates of that point. And if you've done this correctly, you should find that at 3.05 minutes, the speed is, and again, speed doesn't care about positive or negative, the speed is 2.07 miles per minute. The average velocity for the trip. Average velocity is displacement over time, and we've already figured out the displacement. You know how to do that on your graphing calculator. It's negative 1.22 miles, and it's over an interval of 5 minutes. We should get here negative 0.244 miles per minute. The average speed, so average speed is distance over time, and that's going to be equal to 5.66 miles over the 5-minute interval, and that's going to give us an answer of 1.13 miles per minute. Last couple questions here. At time equals 2, what is the car's acceleration? Well, the graph up the top there is velocity, so we're looking for the derivative of the velocity. Right? So if we're looking for acceleration, we're looking for the derivative of the velocity function, right, which was the y1 function. So if you're looking for the acceleration, you're going to want to, on your calculator, do second calc dy dx. Uh-oh, running out of time. And when you do that, pause. And if you pause the video, then my computer battery will be saved and we can probably get through till the end. So I encourage you to pause, try this on your calculator, and then come back. And when you come back, when you're back, you should check to see that you've got negative 2.8 miles per minute squared. Average acceleration. Well, the average acceleration is, we can define that as the change in velocity over the change in time. So the change in velocity, well, the velocity, if you look at the graph, I'll go pull ourselves back up here at the top. Velocity at the beginning, actually, the velocity at the end was 0. The velocity at the beginning was 0. So the average acceleration, change in velocity, well, there was no change in velocity. So the average acceleration is just simply going to be our 0 velocity at the beginning minus our 0 velocity at the end divided by 5. So average velocity is 0. And then the last question, is the car speeding up or is the car slowing down? At time equals 3, so at time equals 3, the velocity is less than 0, and you can get that from the graph. And the other thing we can get from the graph is that, so we're up here, so at 3 the velocity is negative. The graph here, we are concave up. So if we're concave up, that means that the second derivative is positive, and the second derivative is the acceleration. So we know that the acceleration is positive, which then means that we are slowing down. And we're done with the second page of notes.